Hi there, another multimeter, and it's another KAIWEETS, the KM601 to be precise. For full disclosure, I marked this video as sponsored because KAIWEETS kindly sent me this meter for free, but I will of course still provide an impartial review. The KM601 is their current flagship, marked as a 10,000 count smart digital multimeter. It's one of these meters that have no conventional rotary selector to pick the function you want to measure, like volts or resistance diode and so on. Avoiding this method can be a good thing because the rotary selector in the multimeter sees a lot of use, and especially on budget multimeters, the contacts or mechanics are often the first thing to give problems, my old Aneng AN8008 being a case in point. So anyway, what we've got? A manual and a nice zip back. Wow, this thing is way bigger than I expected, and quite heavy too. Some leads and the usual K-type temperature sensor, and 2 sets of 3 AAA batteries. To get into the battery compartment, you have to first get the meter out of its protective holster, which isn't the easiest thing. Maybe it stretches a bit once you have done it a few times. Anyway, once out there, there's one screw to open, which is going into a metal threaded insert. Nice touch. But it's still far from obvious how to lift the cover. Finally, let's put in 3 of the AAA provided with the meter in. The polarity markings on this all-black meter are not the easiest to see. A beep, the meter turns itself on automatically. A big auto, obviously it means we're in the auto function selection mode, and the display of a stylized rotary selector on top keeps flipping between volts, ohms and continuity. The secondary display shows the meter temperature in degrees Celsius. It takes quite a hard and long press of the power button to turn it off. And speaking of buttons, apart from that power button on the top, there's a button for a torchlight on the left, and on the right we have a button to enable or disable the automatic power off function. On the top, next to the red power button, we have another raised button shaped thing, which is actually the NCV antenna. Not the greatest design. Many times when blindly trying to turn the meter on or off, I found myself pressing the antenna stub instead of the power button, but maybe that's just me. To get inside, which you have to do for example when replacing a blown fuse, you need to first remove the battery cover, because it hides the top 2 of the 4 self-tapper screws that hold the meter together. After the 4 screws are out, I still needed a spudger to get the 2 halves to separate, because they are also held by some clips. The battery compartment is molded into the back shell and connects to the PCB using 2 spring contacts. While a good solution for normal use, this is quite troublesome if you need to power the meter while open, for example for repairs or calibration. I am happy to see that they used proper long ceramic fuses instead of small glass ones that are so often used in meters coming from the Far East. This one is the 600 milliamp one, next to the volts and ohm terminal. The silk screening on the PCB labels it F1, but it shows no value. And its ceramic body is completely blank without any labeling either. And so is the 10 amp fuse on the other side. Close to the 10 amp socket it protects, as you would expect. The fuse is simply called F2 on the PCB. Identically looking fuses and no indication at the holders which value goes where. What could possibly go wrong? Well, if you accidentally swap the fuses, it would be fatal for the milliamp range. The markings on the end cap, in this case the 600 milliamp fuse, is the only way to identify at least the fuses themselves. This is rated for only 250 volts, so do not measure currents at higher voltages. At least it claims a UL certification. The other fuse is similarly marked 10 amps 250 volts and with a UL logo as well. On ceramic fuses, I'm always suspicious whether they do contain the needed sand to quench the arc or not. The 600 mA fuse weighs 2.23 grams and the 10 amp fuse just 2.17. A C-bar 400 mA fuse rated for 1000 volt on the other hand weighs 2.33 grams and a 10 amp 500 volt fuse from RS even 2.35. So the KM601 fuses are definitely a bit on the light side. I crushed the broken C-bar 400 mA 1000 volt fuse to weigh just the parts without sand, and it came to 1.82 grams. So my conclusion is that the KM601 uses proper fuses which, rated for 250 volts only, are thinner walled and therefore lighter than my reference fuses which are all rated for higher voltages. If you think weighing fuses is a bit over the top, compare the 2.17 grams of the KM601 10 amp fuse to this 20 amp fuse of an Arning 870 at just 1.58 grams, and you know which one you can trust and which not. So the fuses are real while only rated for 250 volts. Well, it's not that they are shy about the 250 volt max rating. I like the clear indications on the front of the meter and refreshingly no nonsensical CAT ratings. The battery cover isn't that shy and proclaims 1000 volt Cat 3 and 600 volt Cat 4. It also shows the two fuses, and if we assume they are shown in sequence of F1 and F2, it would match the PCB labels. The writing on the cover is just part of the molding, and being shiny black on matte black actually not that easy to read. I enhanced this image digitally to make the writing stand out. The CAT testing was actually done by an established independent test house in China called NTEC, which has quite a list of certificates including international ones, so the CAT rating is probably valid for a change. I suspect the design of the meter reflects the challenges to meet these CAT ratings. Close to the fuses there are, for example, plastic shields sticking through tracking slots in the PCB. These shields reduce the likelihood of arcs developing between fuse and input sockets or PCB components. The PCB space between the fuses is used for some input protection using sets of resistors arranged in parallel for more current capability and in series to withstand higher voltages. CAT ratings is about protecting the user, and while they tick that box, protection for the meter's electronics is just a bare minimum. Just one PTC and some clamping diodes and transistors. Of note, the two right sockets are for volts, ohm and comm, but the two left ones are for milliamp and amp, and these are split sockets. The two halves in the barrels are separately connected to the PCB. If a test lead is inserted, it bridges the two halves, which allows the meter to detect that a plug has been inserted. A top view of the 600 mA fuse. There's a wire going off on the right which tunnels below the sockets and connects this end of the fuse to the milliamp terminal. The usual 1 megohm resistors to protect the voltage input is done using SMDs, and because their voltage rating is poor, the 1 megohms are realized as a series connector of 5x200K resistors. But the main thing I wanted to point out are the two shunt resistors. For the milliamp we have a MELF brown, black, black, silver, blue, which translates to 1 ohm with 0.25% tolerance, and for the amp range it's a SMD resistor of 5 milliohms right next to it. This meter doesn't have a microamp range, but at least these two shunts are both low values, which means a low burden voltage or minimum losses by inserting the meter into a circuit to measure current. Interestingly, both are on the raised mainboard, which means the current has to travel quite a bit and hop over these pin header connectors, which is certainly an unconventional design choice. As for the other items on the PCB, prominently there is this relay. The moderate contact rating of 1 amp 30 volts DC or 0.5 amps at 125 volts AC means switching takes place only after the incoming voltages or currents have already been suitably reduced and converted. On the left is the brain of it all, a specially designed system-on-chip for 999 count multimeters, the SD7502. I wasn't able to find a datasheet for it, only that it's apparently SDIC's microelectronics top-of-the-line processor for digital multimeters featuring 9999 counts. There is some information for the next lower one, SD7501, for 6000 counts, and it's likely that they are both very similar. The chip has 16K OTP memory, which they claim can replace external EEPROMs. For the software program, using OTP, which stands for one-time programmable, is fine, but it appears it is also used for calibration data. At least the reference multimeter design for the ST7501 does not have any other memory, and I didn't see any in the KM601 either. I guess that to do that, they leave sections unprogrammed, and with the right algorithm and programming voltages, you can then write just this section. If this is how they do it, it means the number of calibrations is potentially very limited. Somewhat unusually, slightly above the main ST7502 is another system on chip. In this case, it's the ST8107. This is a chip dedicated for use in scales, but of course it can be used for anything needing a 20-bit ADC and some processing power in 8K of OTP memory. Why the KM601 needs another system on chip, I don't know. One possibility is that this does the temperature function normally shown in the secondary display. The chip appearing rotated by 45 degrees is the TM1729, a dedicated LCD driver. That big square appears to be the buzzer, judging from the silk screening next to it. That soldering close to it isn't the cleanest I've seen. And speaking of hand soldering, there are quite a large number of splashes of solder if you look with a microscope. For example, here next to the hand soldering pin headers joining the two PCBs, those are just stuck to the solder resist and very easy to dislodge by a sharp bump or over time. They can then tumble about in the meter, causing random short circuits. Here's another one right inside the soldering connection of the split milliamp socket. Such stray soldering blobs are time consuming to remove, which is why they often aren't. But let's move on to some more practical matters. The KM601 has no tilting bail, and the reason is that this display is meant to be viewed more or less horizontally. At an angle of a typical tilting bail, the display is quickly fading. All in all, the readability is good as long as you can tame the reflections of overhead lights by the glass front, which acts like a mirror. This is why I decided to leave the protective foil on the glass for now. The leads and probes that came with it look sturdy, and the shrouds necessary for the CAT rating can be removed, which is what I normally do for low energy electronic works. The PVC cable is rather stiff. It is marked apparently 20 AWG and rated 2000 volts. The probes are rated 10 amps and the tips are steel and really more suited for electrician's work instead of electronics. Continuity with the provided leads. And this is the worst performance I've seen in any multimeter ever. It's pretty much unusable. But this is entirely the fault of the leads. With primary leads, continuity is much better. Actually quite good. This meter is really let down by the provided leads, and you should replace the leads as soon as possible. And personally, I don't like the narrow spacing of the sockets. See how close they are when I plug the leads in. Far closer than a standard 19mm. This rules out using adapters like these 4mm to BNC converters, which I use all the time to measure sensitive AC or DC signals. The big question is, of course, how well does the smart auto function work in practical terms? It only covers the first three functions, volts, ohms and continuity, and so I have set up a test consisting of a 9 volts DC battery, an AC powered light bulb and two terminal strips with a wire and a resistor. DC voltage, AC voltage and frequency, continuity, resistance, and so on. Actually, I'm quite impressed. This works really quite well, and I certainly could get used to this. In this test, I connected the meter permanently across the AC light bulb. When turning the AC power off, it reverts to continuity with a really loud and annoying beep. Turning the AC power back on and it switches automatically back to measure AC volts and frequency. This is as you would expect, but I really wish one could select the continuity beep off or at least lower the volume. Using this meter late at night at home or in a shared lab or in a school environment will soon earn you angry comments. These days I always include a test with an AC plus DC signal because many multimeters have problems handling DC in auto mode. Here the 100 Hz square wave signal I'm using has a duty cycle of 50% and hence it's a pure AC signal of nearly 12 volts RMS. Changing the duty cycle allows me to generate any kind of mix between AC and DC on top of one another. Now the signal is almost entirely a DC signal of 9.5 volts with just 7 volts AC, and the KM601 handles this with no problem. It automatically detected that now the DC component is higher and switched to show that instead of the AC. That's pretty impressive. To check if the same works for negative voltages, I ran the same test but reducing the duty cycle, and again the KM601 smartly switches automatically from AC to DC as soon as the DC voltage exceeds the AC. At the time I did the previous test I did not think of trying this, so I had to repeat it. But what if you did not want the KM601 to switch automatically to whatever is the highest voltage? It turns out you can override this behavior. By a long and hard press of the auto button, you turn the smartness off, and now you can select manually between seeing AC or DC volts by using the cell key. To finish the practical handling part, the KM601 uses blinking LEDs to show you what sockets to use for the smart mode, and if I had selected milliamp or amp, the LEDs for these sockets would blink instead. But since the KM601 is using split sockets for milliamp and amp, it can detect if a lead is being plugged in and immediately switches to measure amps instead. Taking it out, it now complains that there is no lead, or maybe that you plugged it into the volts range by mistake. You can also plug it into the milliamp range, and that makes it selecting milliamp automatically. This is a pretty good solution, especially for beginners, and I like it. When in amp or milliamp mode with the leads plugged in, you can't switch to another function. This avoids the usual accidents of leaving the leads in current mode and switching to measure voltages. A sure way to blow the fuses or worse. But you can still do that, of course, if you forgot that you're in the amp mode and stick the leads across a voltage. Possibly more so with this smart meter that normally does all the switching for you. Apparently for that reason you are treated to a quick reminder beep every 10 seconds while you are in the amp mode. Another slight annoyance is that the function button only goes one way. So I wanted to select diode mode, but accidentally I pressed one time too many and ended in capacitance. Now I have to either keep pressing function until I've gone all the way around and start again on the left, or do a long press to turn auto on, which goes back to the left immediately, and then start from there again. Oh no, too fast, and I overshot again. One more time. I wish the function button would work like a rocker switch, allowing left and right presses. I decided not to show the boring verification of the measurement accuracy of volts, currents and so on. I did everything, of course, and the summary is in this table. Pause if you want to study it for longer. I should point out that I was using the specs in the printed manual that came with my meter because I noticed some websites list slightly different ones. The KM601 passes all tests and is well within its specification, quite a bit better actually, as is often the case, except for one function, and that is resistance below 10 ohm. Resistance against my references is generally excellent except below 10 ohms, where it goes beyond 1% error, and the lower the resistor, the worse the problem becomes. Let me demonstrate what I mean. I'm using a BM235 here as a meter of similar price and resolution in the resistance mode to measure a 0.5 ohm 0.1% reference resistor. The meter shows slightly more because of the lead resistance, but with these thick wires that's barely an issue, and I can compensate for it, of course, by connecting the two leads and pressing rel. And repeating the measurement, I get the expected result, 0.5 ohm. And this should be 1 ohm, which it is. 2 ohms now, and finally 2.5 ohms. On the KM601, the smart mode detects the two leads connected to each other as continuity mode, and we get a really annoying loud beep until pressing the auto function button to turn smart off and select ohms manually. The two leads together read 0 already, so rel would be useless. Measuring the 0.5 ohm resistor shows 0.1. There's no point in using rel even if it was greater than 0, because that would make the result even worse. 1 ohm reads 0.5, 2 ohms as 1.4, 2.5 ohms as 2.2 or 2.3. And while investigating this, I noticed that the user manual that came with the meter lists one more range, 99.99 ohm with 0.01 ohm resolution, that is not implemented in my meter, which doesn't go lower than 999.9 ohm, and this could certainly be related to this issue. Of course, I contacted KAIWEETS about this, and their response is in this box. The gist is that this is a limit of the meter, but there's nothing to worry, as it still meets its spec. This may come as a surprise to you, since on the face of it, showing 0.1 ohm instead of 0.5 is a whopping 80% error, way beyond the claimed 1%. But common to pretty much any multimeter, the accuracy is specified as a percentage plus digits, in this case 1% plus 5 digits. To understand what this means, consider the plot on the right. It shows true resistance against display resistance. The blue line is what an ideal, totally error-free meter would show, which is of course always exactly the true resistance. The red lines are the limits based on the plus minus 1% and 5 digits. To be in spec, the KM601, which is the green line, needs to stay within these two red lines. And it does. Well, just about, but let's be generous here, because I did not measure enough samples, and this is right at the resolution limits of the KM601 anyway. Does it matter? Well, if you need to do a lot of highly accurate below 10 ohm measurements, the KM601 is obviously not for you. Not much to say about diode measurement. It can measure a single diode, of course, and 2 normal diodes in series is also not a problem. Thanks to the charge pump, it can measure a single red LED, and 2 in series do light up, but it does not show the forward voltage. Lastly, NCV. It works, but is maybe slightly less sensitive compared to other meters with NCV I have used. To be fair, regardless of the meter used, I would never trust NCV to determine if power is on or off. The live function works as it should, and again, and unrelated to the KM601 or any other meter, I would not trust the absence of NCV live indicator as proof that live is really off. With this massive display permanently illuminated, a big question I had is power consumption. Fortunately, measuring this is easy in the KM601 using 2 test clips, but please never do this and try measuring something with a meter. As with any multimeter, your safety depends on using batteries and keeping the battery cover closed. The meter at 4.5 supply voltage uses between 31 and 32 milliamps regardless of mode, which jumps to more than 46 milliamps when the buzzer is working. That's quite a lot for AAA batteries. When turning the power off, the sleep current is initially 10 microamps but rises slowly to slightly above 12 microamps. This means you should take the batteries out if you're not going to use the meter for a long period. By gradually reducing the voltage shown on the red meter, I try to establish when the low bat indicator comes on. It happens just below 3.59 volts. This means about 1.19 volts per cell. This is relatively early for alkaline batteries. Here's a typical AAA alkaline battery. Other brands are of course available. The KM601 power consumption is somewhere between 25 and 100 milliamp bars. This would equate to between 31 and 37 hours of operation. But these capacities assume a discharge to 0.8 volts, and as the typical discharge curve on the right reveals, showing a low bat at just below 1.2 volts, that is nowhere near using the energy in the cell, which is the area under the curve. So maybe we get just 24 hours of operation out of one set of batteries, and they are not really empty. Switching to typical nickel metal hydride rechargeables is a better option. These start with less voltage but keep it more constant and typical just above 1.2 volts for most of their charge. The 700 milliamp hours of this battery should run the KM601 for almost 21 hours. Alerting at just below 1.2 volts really indicates that the batteries are at an end. The slight problem is that with rechargeables there really is not much more in the tank once that indicator comes on. And the trouble with the KM601 is that once the supply drops below when the low bat indicator comes on, the readings start to change. The 5.008 volts are constant, but the KM601 reads less and less the lower the battery voltage drops. Well, and eventually, sometimes the display just fades into dark and that is it, but more often it does not go so quietly into that good night. So what do I think about the KM601? It is certainly a competent multimeter that covers all functions you would expect at a decent enough accuracy except for very low ohms resistance measurements. It is neither a fluke or a primer, but its safety features protecting the users in terms of fuses containment and arcing prevention seems better than most multimeters in that range. That said, the protection of the meter circuitry itself isn't great. One should stay clear of possible sources of static electricity, electromagnetic pulses and discharges. I think the way the KM601 guides the user regarding what sockets to use for what and prevents and warns and detects misconfigurations of the measurement leads makes this meter well suited for beginners. Sadly, the provided leads are not very good for electronics, and if that's your main use, I recommend replacing them as soon as possible. The overslit display is easy to read and even with little or no ambient light. That and the built-in torch light make it well suited for chasing wiring problems in dark areas like behind car dashboards or footwells or basements. Of course, that comes at the price of a much higher power consumption than meters with just an LCD screen. I have replaced the provided alkaline AAAs with nickel metal hydride rechargeable batteries and this works really well. Lastly, the novel smart function of this meter works really quite well and I can see its attraction, especially again for beginners. If only one could tame the loud continuity buzzer. It comes on whenever the meter detects no voltage and a relative low resistance. In practice that happens a lot, but why do I need to wake the whole neighborhood? I think overall it's a good meter with some room for improvement, but then which meter doesn't? It is solidly built and the mobile phone form factor of the KM601 will appeal to many beginners because they are used to it rather than the sometimes overwhelming look of traditional multimeters. I think the KM601 is an excellent meter for beginners and I will test this by passing it on to a beginner in the family as their first multimeter to see how they're getting on with it. If you have not subscribed already, hit that button and the notification bell so you don't miss the next video and maybe consider becoming a Patreon, link in the description. As a Patreon you get early access to videos, a blog and other exclusive content. Thanks for watching.